This animation shows a qubit, quantum versions of the most basic pieces of information, called bits, that tell home computers, tablets, or cell phones what to do. It also shows how researchers say they have solved one of the big problems of quantum computing, that photon-sized qubits have to be so close together, nothing could go around them.
So until now, we did know how to make quantum bits in silicon, and we knew how to couple a few of them in a small prototype quantum computer. What wasn't clear yet was how to integrate these quantum bits with the size of the classical interconnects and readout transistors that you need to actually operate a large-scale, powerful quantum computer that does useful calculations.
What that means is that these new qubits, called flip-flop qubits, can be far enough apart to surround them with the normal-sized electronics that make up our current computers.
Using flip-flop qubits instead of normal qubits means that we now have the space in between the qubits to put the classical control electronics. And this will make it easier and quicker and cheaper to manufacture using essentially the same manufacturing technique that is already used in every computer and mobile phone silicon chip.
Morello's flip-flop qubits can also be manipulated with electric signals instead of magnetic ones.
Electric fields instead can couple to an atomic scale object much more strongly, so you need less power, and moreover, the effect on the object that you want them to couple to falls off much quicker. So you can actually localize and decide, I want to operate just this qubit and not the other qubit.
The big idea here is that this is a pathway that could allow quantum computers to be built with the same electronic components used to build today's computing devices.
The impact of this discovery is that we now have a clear plan and pathway to build a large-scale quantum computer in silicon where the integration between the quantum bits and the classical control electronics is much easier to do.
If this technology actually works on a large scale, it will pave the way for home computers that can do things even today's largest supercomputers could never do. The Australian team hopes to have a working quantum computer by 2022. Kevin Enochs, VOA News.